So we're going to use completing the square to move from the standard form to vertex and to factor form all in one process here. Okay, so we have our standard or vertex and our factor form, and these are they're written with their unknowns or their variables in them. And this is the one we're going to work with. Now this one is a little more complex because it doesn't have very, very nice values to it. Actually, quickly just to show you, you'll notice that if we were to factor this traditionally without using quadratic formula, it'd be really hard because we don't have integer values, and the vertex isn't quite that nice. The y-intercept works out pretty good. So what we're going to do here is we're going to go through the process of completing the square, and then I'm going to show you how at one step we're going to split it. And at one point we'll go to vertex, and the other we'll go to factored. We'll get all three forms in one process. So normally when you complete the square, if you're going just a vertex form, they might tell you just to take the a value, or the coefficient of the x squared, and divide the first two terms. But we're actually going to divide all three terms by it. Okay, so because the a value is 3, we're going to divide all terms by 3. So the c value is now going to become a fraction for all our purposes. So we now have an a value of 3, and that makes a lot of sense because in all of our forms here, that's going to be our a value. That's going to be our 3. So we've already figured out the a. Inside the bracket, we'll have x squared minus 3x. And I'm going to leave this as a fraction, plus 4 over 3. Okay. Now we have what's considered our new b value. And a lot of times what they ask you to do with this is our new b value, we're going to divide it by 2 and square it. So our negative 3, when we plug that in, we get negative 3 over 2. Okay? And instead of making that a decimal, I'm just going to square the fraction. So we're going to get 9 over 4. And that value we're going to add and subtract within those brackets. So that's a value we're going to add and subtract. So when we go to put it in here, we have our f at x is equal to, okay, we still have our 3. And what we're going to do is we're going to put that value just after our new b value. So we're going to add 9 over 4 first, then subtract 9 over 4. And then we still have our positive 4 over 3 here. Okay, so I'm going to collect these two terms and turn them into something. Okay, we'll put them into a simplified value. And here, what we've created is a perfect square trinomial. So we can square root the first and the last term and just take the value or the operation in front of the b value, and we're going to almost factor it. It's still going to all be within a bracket. So we have our 3. Okay, and when we factor this, okay, I'll kind of put it in blue here. Like I said, we square root that, so we get x, subtract, and square root of this would be 3 over 2, okay, and squared. So we've just factored our perfect square trinomial, and we're going to put these two together. Well, we need a common denominator, so 4 and 3, that'll give us a common denominator of 12. So multiply the top of this fraction by 3, so 27 over 12. And the other one will multiply the fraction by 4, so we get positive 16 over 12. So we still need to simplify that outside term. So we get our 3, our brackets, x minus 3 over 2 squared. And this will become negative 11 over 12. Okay. So from here is where we make our choice. We can go to the vertex form from here. And when we do that, what we'll do is we'll take this negative 11 over 12 and pull it outside of this bracket. And when we do that, we'd have to multiply by our a value. So our new function in vertex form, f at x, is equal to 3. Okay. We'll have x minus, this is our h here, so 3 over 2 squared. And when this comes out, we multiply by 3, it just becomes negative 33 over 12. That's some decimal value. But there's our vertex form, with everything being very, very exact. What we can also do is we can continue down to turn it into factored form. Okay, so we're not going to take this out. In fact, what we're going to do is we're going to find the square roots of this term here. So we're going to kind of square root both of them. Okay, there's a reason we're going to do this. So we get 3, we're still all within the brackets, x minus 3 over 2 squared. And what I'm going to do is minus the root of 11, okay, over the root of 12. So we square rooted both of them, squared. Okay, and the reason I can do that is I square root and put something to the power of 2, it eventually just, or essentially just becomes the value underneath the square root, which is our 11 and 12. So I've just kind of changed the way it looks, just like our when we add and subtracted 9 over 4, we really haven't done anything to the equation. But what we have set up here is, if you remember your factoring rules, we've set up a difference of squares. I know my writing isn't very nice here. And if you recall difference of squares, you might have something like x squared minus 16. And you can square root both of those. And to put them into new brackets, we take the square root of the first term, it's the first in both, and square root of the last term is the last term in both, and we just add and subtract, them. So we have a difference of squares. This is our first term, and this is our second term. Okay, we'll highlight them here. It's our first term, and this is our second term. So I'm going to square root both of them. The 3 are the a value of 3 still stays the same, so I have 3 outside, and we're going to make 2 brackets like we said. So the first term in each bracket will be x minus 3 over 2, because the square root of this essentially just cancels out the squared, and the same thing will happen over here. Okay, and we get x minus 3 over 2. And the square root of this becomes, well, we would just cancel out, our power of 2. Okay, so that kind of disappears. So we would have the root of, we'll do it in blue. We'd have root 11 over root 12 and root 11 over root 12. And like we said before, we add and subtract that value. So we're almost in our factored form. We just have to combine whatever these are. So we could use a calculator to figure that out. Technically, this is an acceptable factored form. I'll show you on a graphing calculator what those exact values be. I'm going to leave it this way so that it's as exact as possible. And we're technically now shown in one process, not one step, many steps to this. A vertex form, a standard form, and a factored form. So if we take a look over here, this was the form we used. We subtracted root 11 over 12 and added root 11 over 12. And when we subtract it, just to find out what the value is, that's negative 2.45. And obviously, when it's in factor form, it's the opposite of that. So we have positive 2.457. Same idea here. When we added it, we got negative 0.54, and we get positive 0.543. Okay, and just with our vertex form, you'll notice 3 over 2 is 1.5, and negative 33 over 12 is negative 2.75. So when I turn on the forms right now, I only have the standard form in. You'll see that the factor form overlaps it, and the vertex form overlaps it. So technically, we've gone to all 3 forms now.